Hello friends. So now let's learn in detail about refractive index or the index of refraction. So we saw in the previous video that sin I by sin r is always a constant, and this constant was called refractive index, and we saw that this is actually dependent on the pair of media. But we did not see how it is actually dependent on the pair of media. So let's say you have a medium, I call it medium 2, and it's surrounded by another medium, medium 1. And suppose there is a light ray falling on the interface, making an angle I. The light ray is going to bend, and since it is moving from a rarer medium to a denser medium, it is going to bend towards the normal. Okay, so let the angle of refraction be R. And we saw that refraction actually happens because the speed of light in these two media are different. So let's call the speed in medium 1 V1 and speed of light in medium 2 V2. So the refractive index of medium 1 with respect to medium 2 is defined as the ratio of speed of light in medium 2 with respect to medium 1. So that means N12, which is a symbol to show refractive index of 1 with respect to 2, is equal to V2 by V1. And similarly, N21, that is refractive index of second medium with respect to the first medium, would be V1, that is speed in first medium, divided by V2. Why I am stressing on this V1 by V2 is because after some time I am sure that you are going to forget this and you will write N21 is V2 by V1. It's not so, you should always remember and be careful. Okay, so now let's take an example. Say the medium 2 is glass and medium 1 is water. So light is entering from water to glass. Glass is denser, water is rarer. So light bends towards the normal. So now we can say that refractive index of glass with respect to water is speed of light in water divided by speed of light in glass. Okay, it's the opposite. I hope you all would remember that. Okay, so now we know more about this constant. We know it is the refractive index, and we also know it's the ratio of speeds. But still we have a problem. Which ratio to consider? N12 or N21? So the answer is, here light is moving from medium 1 to medium 2. So here light is going to enter into medium 2, right? So it would be the refractive index of medium 2 that is going to matter with respect to medium 1. So that means if light is moving from medium 1 to medium 2, then sin I by sin r is refractive index of medium 2 with respect to medium 1. So we have to consider that medium into which light is entering. So now we know more about this constant, so we can replace this constant word and write that sin I by sin r is equal to the refractive index of the final medium into which light is entering with respect to the initial medium, and that is equal to the ratio of speeds, speed in initial medium divided by speed in final medium. But before that, actually I forgot to tell you something. This law is actually called the Snell's law of refraction, and it's a very famous law. I'm sorry I forgot to tell you, and hope that you will remember that this is, and hope you will remember this. Okay. So now let's see the proof. Okay, so now let's see the proof. So for that you should actually know what sine is. But there is nothing much that you need to know about sine. The only thing you need to know about sine is, if the angle increases, the sine of the angle also increases. Okay, so now let's imagine a ray coming from a rarer medium into a denser medium. So you know that light is moving faster in this medium, and slower in this medium because this is denser. So as it enters, we can say V final would be less than V initial. So the ratio Vi by Vf becomes a bigger number divided by a smaller number, which would be greater than 1. So now we know that Vi by Vf is equal to sin I by sin R by Snell's law. So we can say sin I by sin R would be also greater than 1. Now this means sin I is greater than sin R. And since angle increases, sine of the angle also increases. You can say I would be greater than R. That is, I is greater than R. So the ray actually bends towards the normal, so that I is less than R. So that's the proof for why light bends towards the normal using Snell's law. Now let's see another important terminology related to refractive index, that is the absolute refractive index. So absolute refractive index is simple. It is just the refractive index of a material with respect to vacuum. So if instead of this water around there was nothing, that means the medium one was vacuum, and imagine a ray falling just like the previous, but this time the speed of the ray would be the speed of light in vacuum, which is a universal constant. We represent it by the letter C. Now we can find the refractive index of glass with respect to vacuum. It would be the speed of light in vacuum divided by the speed of light in glass. So the refractive index of medium 2 with respect to vacuum, for which we use no subscript, is called the absolute refractive index. And the speed of light in air is very close to the speed of light in vacuum. So we can also say that the absolute refractive index is the refractive index with respect to air. This is not true, but for calculation purposes it is a very good approximation. So for example, the speed of light so as an example, the refractive index of water would be speed of light in vacuum divided by speed of light in water. And similarly for glass, it would be speed of light in air, vacuum, divided by speed of light in glass. Okay, so now it is also possible. Now here is a table showing the all possible. So here is a table showing some of the important. So here is a table showing the absolute refractive indices of some important materials. So we can see the refractive index of air is 1.0003. So small. This means the speed of light in vacuum is only 1.0003 times greater than the speed of light in air. So that is a very negligible difference. So that is why this statement is valid. Okay, and we see that water has a refractive index of 1.33. Glass has an absolute refractive index of 1.5, and diamond actually has the highest refractive index, and it has a refractive index of 2.45. And it is also possible that sometimes you are given with these absolute refractive indices of objects, like you are given refractive index of water and glass, and you are asked to find what would be the refractive index of glass with respect to water. So if you are just given the absolute refractive indices of water and glass, can you find the refractive index of glass with respect to water? Actually you can. So what is refractive index of glass with respect to water? It is the speed of light speed of light in water divided by speed of light in glass. And if you see these equations, speed of light in water is C by NW and speed of light in glass is C by NG. So what would be VW by VG? It would be simply dividing them. C gets cancelled and you would get NG by NW. So now you all can be happy because you have something that is following a non-opposite relation. So refractive index of glass with respect to water is refractive index of glass divided by refractive index of water. So I think we can add this also to this equation. So we get sin I by sin r is refractive index of final with respect to initial, which is nf by ni, and that is equal to vi by vf. So that's all about refraction. So now we are going to see refraction in spherical surfaces, and that will be in the next video. So till then, take care. Have a nice day.